Let's look at how antigen detection RDTs work. Most RDTs are based on a cassette format, which will look similar to what you see here. Inside the cassette, you will find a strip, which is where the immunochromatographic reaction happens. This strip is composed of a nitrocellulose membrane, which is flanked by two absorbent pads on each side. The purple part that you can see here contains what we call the conjugate. The conjugate is actually an anti-antigen antibody that is conjugated to colloidal gold, which gives it the purple, not golden color. On the test line, what we find is an anti-antigen antibody. And on the control line, we find an antibody against the conjugate. Now what happens if we add a drop of blood from our patient that is infected with, for example, malaria, so the blood contains an antigen of the parasite. The antigen will bind to our conjugate as it is composed of an anti-antigen antibody, and everything will start migrating. And as the test line is composed of an anti-antigen antibody again, but this time against a different epitope. So as you can see here, as the conjugate kind of grabs the antigen by the head, the test line antibody will grab the antigen by its tail. And since the conjugate has the colloidal gold conjugated to it, the test line will turn purple. And those conjugate antibodies that did not bind any antigen will continue migrating until the control line, where they bind to the anti-conjugate antibody. This will color the control line purple. Now what would happen if we added a sample without any antigen from a patient that is not infected? Well, no antigen is present, so nothing will bind to the conjugate. Still, of course, the conjugate antibodies will migrate, but they will pass the test line and bind to the control line. So in this case, we only have a purple control line. Let's talk about a very important, because very dangerous effect in actually all serological assays, the prozone or high-dose hook effect. The prozone effect happens when we have a sample which is full of antigen, usually caused by hyperparasitemia. If we add a blood sample which is full of antigen to our strip, the antigen will bind to the antibodies of the conjugate, but there are more antigens than the conjugate can bind, so free antigens will remain. Now, as migration starts, free antigens will migrate faster than the antibody-antigen complexes. This leads to an absorption of the test line by the free antigen. Since the free antigen is not coupled to the conjugate, hence there is no color, the test line will remain clear, while the antibody-antigen complexes will continue to migrate, and whether they bound an antigen or not, they will bind to the control line and color the control line purple. This means that we have a false negative result in a case where we have a very high dose of antigens. This is, of course, a very dangerous effect, as you will miss high infections. How does the backflow effect work? Well, again, we will have a sample without any antigen, so no antigen will bind to the conjugate. Everything will migrate. The control line will turn purple, and the rest will continue to migrate. If now we wait for too long, the strip might dry out, and what will happen is that the antibodies might migrate backwards. Now, the problem with this is that if we look at the strip from the side, as you see here, there is a den where the test line has been coated. If we have reverse migration because the strip has dried out, the conjugate that did not bind to any antibody on the control line, they might get stuck in this little den and hence cause a false positive readout. This backflow effect will lead to false positive results if the test is not read within the recommended time of reading.